This is the crash course on reference angles. Every single angle, big or small, has a reference angle. It all depends on what quadrant the angle terminates. Alright, so if you have an angle that terminates in quadrant 1, this is the easiest scenario. Your reference angle is your angle. Now the symbol for an angle, we always say, is theta. But for a reference angle, it's going to be theta with the line over it. Sometimes you see it written as theta prime, but normally I use the line above it. So in this case, guys, the angle is our reference angle in quadrant 1. In quadrant 2, you have to do a formula. So here's an angle that terminates in quadrant 2. Here is my angle theta. This angle right here, that is my reference angle. So to find that reference angle in quadrant 2, you're going to do 180 minus theta if it's in radians, or pi minus theta if it's in radians. Alright, now for quadrant 3, angle terminates here. Alright, here is your angle theta. Got to put my arrows there. Here's theta. And your reference angle would be this angle here. So to find that reference angle, you're going to do theta minus 180 for degrees, or theta minus pi. Alright, 2 and 3 look very similar, so be careful, don't get those formulas confused. And then for quadrant 4, the angle terminates here. And there's theta right there. Our reference angle is this small angle here. And to find our reference angle, we do 360 minus theta, or 2 pi minus theta. That should be a 2 there. 2 pi minus theta. Now, those are the formulas for each of the 4 quadrants. Just a few tidbits, guys, in regards to reference angles. Your reference angle is always positive. It will never be a negative number. So it's always positive. If for some reason you got a negative number, you did the formula wrong. The other thing is your reference angle is less than or equal to 90. You'll never have a reference angle bigger than 90 because it's going to change quadrants. And the last rule, which is not one of the official rules, is that if theta is bigger than 1 revolution, your original angle, take away a revolution and then find theta. So take away a revolution. You have to have an angle less than 360. Take away a revolution. And I'll show you an example here shortly. So those are just a couple of little small tidbits regarding that. So let's do a few quick examples. Let's say we had 220 degrees. You want to find the reference angle. Always draw the angle. Don't try to think about it in your head. 220 starts here. That is going to terminate in quadrant 3. So here's my angle. Well, this is quadrant 3. I'm looking for the reference angle. So I'll use my formula for quadrant 3. The formula will be theta, which is 220 minus 180 degrees. So that is going to give me a reference angle of 40. And there's your answer. It's all subtraction. No more, no less. It's pretty straightforward on that. Let's try another one. Let's try one in radians. Let's do, let's see, 6 pi over 7. Okay. Well, remember how we graph radians? It's always easier to convert to a decimal. So I'm going to grab my calculator here and go 6 over 7. That's 0.85. Or we can say 0.9, pretty close. So this is about 0.85 pi. So when we graph that, it starts here, 0.8. Let's see here, that's 0.5, 0.85, about right there. So this is quadrant 2. Alright, so we want to find the reference angle, which in this case is in quadrant 2. It's going to be right there. There's our reference angle. So we're going to use a formula to find it. Well, in quadrant 2, we do pi minus theta. So pi minus theta, which is 6 pi over 7. If you don't feel comfortable with fractions, use your calculator. 1 minus 6 over 7. Remember, we replace the numbers without the pi, and you're going to get a decimal, math, enter, enter, and we get 1 over 7. So our reference angle is going to be pi over 7. And that's how you do one in radians. One last example here. Let's say you had an angle of 500 degrees. Alright, clearly that is bigger than 1 revolution. So the first thing I'm going to do is take away a revolution. And you're going to end up with 140. And now that is something I deal with. So you're going to go ahead and graph 140. And you start here. And 140 is going to be in quadrant 2, about right there. And we're looking for the reference angle, looking for this angle here. So we simply just do 180 minus theta, and the answer will be 40 degrees. If you're given a negative angle, just do the angle like if it was positive. You get the exact same answer. So if this was negative 500 degrees, just pretend it was positive and do the exact same thing. Okay? All right, in the next lesson, there are 2 more examples, which I'm going to show you an example of each. So this is kind of 2 lessons in one. Here's a different kind of question. They give you a point 2, -4, and want to know what is the trig ratio for all the angles at the reference angle. Well, guys, you're going to have to draw a picture to see this. All right, so I'm going to draw my x-axis. I'm going to draw my y-axis. I'm going to graph 2, -4. I'm going to go to the right 2 and down 1, 2, 3, 4, and I have a point. The angle terminates at that point, so my terminal ray will go through that coordinate. All right, remember, it still starts here. So here's theta. Okay, we don't know how to find it just yet. Don't worry about that. But we're going to make what's called a reference triangle. Okay, just like reference triangles always touch the x-axis. So here is theta. Here's my reference angle. Well, how do we know the size? We went to the right 2, we went down 4. The negative sign is crucial. You go down 4. Pythagorean theorem to find the missing side. So I'm going to do that over here. 2 squared plus -4 squared equals my hypotenuse squared. That is going to be 4 plus 16. So my missing side is going to be the square root of 20. Once you have that, guys, you're home free. Find all your ratios. Sine is opposite over hypotenuse. Cosecant is adjacent over hypotenuse, and tangent is opposite over adjacent, and then you just flip it for the other ones. And that's how you do those examples there. Alright, now for the last example, it's very similar, but it's just set up differently. Okay? In this example, as soon as I can get it to show up here, let's see here. There it goes. Alright, in this example, I tell you that cosine theta is -4/5, and the angle terminates in quadrant 2. Alright, so this is given to you here, as soon as it pops up here. Okay, there's a problem. So, I'm going to go ahead and draw an angle, any size angle that terminates in quadrant 2. So, here's quadrant 2, boom, here's my angle. Alright, I'm going to go ahead and draw a reference triangle, just like we did. Now, here's theta, my reference angle. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Remember, this 4 is negative because it's going to the left. Your hypotenuse is always positive. Now all you have to do now, guys, is find all your trig ratios from this triangle. But you got to do the Pythagorean theorem. You do that, this side is going to be a 3. So I'm just going to do a few here. Cosine is adjacent over hypotenuse. Sine is hypotenuse. I'm sorry, opposite over hypotenuse. And of course, tangent is opposite over adjacent, and then you flip them for the corresponding trig functions.